Yeah, what's going on? I'm Cory Phillips, Program Director at ARPA-E. We're excited to have this conversation with our panelists who are about to introduce themselves about the opportunity to do reimagining in manufacturing. It's a discussion that we have in the office quite a bit, but we have some really great people here today, and I'm excited. So Jim and I are going to go back and forth.
Yeah, I mean, you can't keep Cory off the stage today. It's just the way he is, but I'm sure you know that by now, so appreciate your patience with that. So, Diana, if you can.
Sure. I'm Diana Bauer. I'm the Deputy Director of the Advanced Materials and Manufacturing Technologies Office at DOE, and AMPTO, which is an office, is within energy efficiency and renewable energy. We focus on innovation for innovation to transform materials and manufacturing for our energy future. And we have a wide range of programs and activities ranging from critical materials, making those supply chains more secure, to near-net shape manufacturing of large components greater than 10 tons, to very small microelectronics and semiconductor manufacturing, and pretty much everything in between. We're also very into smart manufacturing and AI-informed manufacturing. So we're very excited and delighted to be here today. Yep.
Go ahead, Jay.
Yeah, I'm Jay Lee. I'm Professor and Director of the Industrial AI Center at the University of Maryland. Our focus is really to develop and deploy non-traditional machine learning for highly complex industrial systems, like semiconductor fabs, fleet of jet engines, fleet of wind turbines, and etc. So we deal with a lot of uncertainties and develop good, useful technologies. Thank you.
Hi, Amy Linsebigler here. I'm from the GE Vernova Advanced Research Center in upstate New York. The GE Vernova Advanced Research Center works with all of our GE Vernova businesses, gas power, nuclear, our grid, and renewables business, to develop technology that they use to actually provide reliable energy to everyone in the world. GE Vernova actually produces 25% of the world's electricity. So there's a huge responsibility for the research center to be at the forefront of developing technology that matters.
Good morning, everyone. My name is John Palamara. I'm the General Manager of Honeywell's LNG business. Honeywell's a well-known industrial supplier, known for aerospace, defense, both business and building automation. We also play a very large role in the LNG industry. So it's our technology and equipment goes to the heart of LNG export plants. About 2/3 of the world's LNG is produced with our processes and equipment.
Wow.
And so I'm very, very proud to be here today talking about infrastructure and legacy infrastructure.
It's great. I have a few housekeeping things, Jim, before we get going with the questions. So to the audience, as we're going to get to a point where we want to hear from you as well. So there is a QR code. If you scan this QR code, and we have this on our app as well, but scan the QR code with your device. You can download the app and then look into the summit agenda, and you can find the session that you're in right now. And then there's something called audience Q&A in there. And when you get there, you can type your question in, and it'll go right to Jim's iPad, and he'll look at it and decide if he wants to ask your question or not. So good luck with that.
Oh, thanks, Cory. So, why don't we dive on in?
Yeah,
and
as
long as we're talking about manufacturing, why don't we start with Diana here, and we can move on down, answering the question of what are the most significant factors contributing to the U.S. manufacturing strengths?
Okay. Well, I think that what's really important for strong manufacturing innovation is one thing. Having the infrastructure in place is a second thing, and having the workforce is a third thing. So being able to support innovation that gets us to the next generation of manufacturing is really important for long-term strength or strength moving forward in manufacturing. The ability to scale up those innovations is also important. So having that infrastructure, also having the funds available, and then finally the workforce. The workforce needs to develop its skills to be able to be cutting edge with the rest of the, with the wave of manufacturing that's coming. And we want to be integrated sort of across the supply chain. So we're manufacturing at each stage of the supply chain, so we're more secure, less vulnerable. And AMTO is very focused on building, sort of bringing all of that together and supporting innovation ecosystems that really help build communities of, large companies, entrepreneurial companies, small companies that can bring these pieces together. So I think that's my answer.
And Diane, that's across the entire, you said supply chain as well, so that's across the entire supply chain.
Yeah. So for example, in critical materials where we do a lot of work, there's a vulnerability right now in processing and refining separations. Oftentimes mined materials go elsewhere to be processed and separated, and then they're not here.
Yeah.
So that introduces a vulnerability in the supply chain, and we're trying to address that.
Thank you. Jay, any comments?
Yeah, well, manufacturing, right, is a foundation of industry. So it has a basic elements, right? Materials, I agree with you, foundation. You have to innovate, accelerate. Machine, you have to build, innovate, make a dominant. And methods, you have to innovate, constantly discover those unknowns and optimize way, right? Metrology, measurement, you have to measure things for those invisibles. And maintenance, to predict things, not to uncertainties. And finally, we need to develop future models that can really make manufacturing smart and different. So I think the 6M, doesn't matter where you go, you're going to find 6 elements. Then, of course, to make the 6M happen, technology has to move fast. Tools must have a legacy, repository, all industry can use it, and talents have to be continuously resharpened and renewed. I call it 6M and 3P. I believe that's very fundamental for any manufacturing industry.
You're stumping on my 70s. I dropped 70s earlier. Now we got 6 M's and 70s. Thanks, Jay.
Yeah, just to add on to what has been already said, I think building on this, integrating what we need for digital transformation in manufacturing with the physical nature, the innovation, the design, the physical hands-on skills, right? It's going to be an awesome thing when we actually can integrate them together. And then I think there's an element here when you actually take digital transformation in manufacturing and that ability to actually build something, and that is cybersecurity that we need to start thinking about too, right? How are we actually going to do that in a very secure way? And so that's, kind of building on that theme.
And maybe just let me build on some of the answers of my fellow panelists here. Just from competitiveness, from the LNG industry's perspective, U.S. LNG is highly competitive right now on the global stage. And that's why you see the massive build out that's going on and the massive investment in infrastructure. Since 2016, it's added about $400 billion to the U.S. economy and supports about 270,000 jobs in our economy. So really impressive. let me give you a granular example of how innovation works its way into the competitiveness of the industry. So we have engineers right now in Allentown. We have engineers right now in Allentown, Pennsylvania, dozens of them applying innovative techniques and scale up to the heart of these LNG plants. And then they take their designs and plans and we manufacture, with about 400 people at our facility in Florida, manufacture large heat exchanger equipment that is supplied to the heart of these LNG facilities, and some of them right here in the United States. Cove Point, Maryland, facilities in Louisiana and Texas. And so it's really, that's competitive American technology going into competitive U.S. LNG export.
Nice. It's great. And that we've been talking about the importance of exporting as we move forward, particularly with these energy technologies and opportunities. So it's great to have a case study that we can point to that clearly is a standout. You know, they're positioned very well to kind of maintain their position in that area as these exports continue to emerge in the future. Thanks for sharing that, John. And Diane, you mentioned about workforce too, and Amy was kind of touching on that. So there's a lot of innovations that we can move into the workforce as well. Then technical, based innovations that the workforce will need. And I know Jay's involved in that too on the AI side. Jim, you want to?
You want me to lob the next one?
Yeah,
out?
lob the next one out there.
Well, I think this kind of follows up. Let's start with John and then work our way back.
Okay.
I was very interested in looking at the industrial perspective. What are the most urgent short-term steps that can be taken to address the challenges of our legacy infrastructure? So short term, yeah.
It's a good question, Jim. And legacy infrastructure in the LNG industry is a very interesting story. So if I could turn back the clock, let's say back to the 1990s, and the United States is running short on natural gas. Supplies are down, prices are up, and the United States starts to build LNG import terminals. Because the future then was we were going to bring in natural gas from the Middle East, from Asia, to support our needs. At that point, industries were offshoring, due to high costs. And then the oil and gas, and then around 2005, 2008, the oil and gas industry applies new technology to subsurface shale gas that everybody knew was there, but they have the technology now to unlock it. And I think everybody in the room probably knows the rest of the story. What was interesting about the LNG industry is from that point in 2008, these import terminals that had really large ship berths and large tankage and transfer technology, ship to tank transfer technology, those actually turned into the first LNG export plants. So it's a tremendous story of taking legacy infrastructure and instead of looking at it as something like a millstone, turned into an opportunity. And that's kind of the story of the LNG industry. I think it's instructive too for us today, and you can see the quick pivot because say 2016. The first large exports were made. 2023, the U.S. is #1 in LNG exports in the world. Wow. So it's things can happen quickly when the public policy is aligned with economic interests, private investment. It can happen.
And there's a technology thread in there too. I mean, along the way. So, from your standpoint, was there investments made even prior that 7-year sort of I would call it that 7-year sprint that happened? What was it like before that in terms of the investment in the technologies that help spur that along?
You're talking about the shale gas.
Yeah.
So I'm not a subsurface guy, so I'm not probably the expert on that. But I mean, I think it's well known the directional drilling, seismic, the things that really just unlock vast resources here, and you can see it in any chart of how we've used energy over the years. 2008 was the start of something brand new, so pretty magical.
The reason why I kind of threw that one at you is because I want the audience to realize that there are time scales where early stage investments in technologies that seem like very risky. There was a time where that type of drilling technique was not accepted. Jim and we came out of oil and gas, so there was a time when people shied away from that because of the cost, right? And so at some point the cost curve and the need allows for bets to be placed that weren't normally placed on technologies. And we heard from this case here, John, this is a great case where in 7 years, if you get the technology ready, you can accelerate it really into the marketplace if the market's ready and all of the forces align themselves. So thanks for sharing that. I just wanted to bring it back home for the audience here, so thanks.
Yeah. I mean, and again, Cory just added a small piece to that too, is having those import terminals, which were a significant capital outlay. You're able to take advantage of that, and then that obviously helped greatly with that acceleration. So again, you couldn't really foresee that, but just building things and it will come actually did happen. So anyway, not to say it should be a practice, but in this situation it was fortuitous.
Kind of
worked out. Yeah, go ahead.
Yeah, so for GE Vernova, I think it really is a recognition that investment is needed and for our legacy manufacturing as well as new manufacturing lines. And so GE Vernova just announced, $600 million investment in US-based factories to actually improve and have new lines and improve the legacy manufacturing lines that we have. But not only that, also an investment in the actual innovation center in upstate New York, the Advanced Research Center. There's $100 million going there to help us accelerate those technologies that we want to bring to bear on gas turbine development, on small modular reactor development. So really that recognition that investment is needed in those legacy production lines is huge.
So Amy, so R&D, you all connect to these legacy manufacturing scenarios that you mentioned. There is a pathway for your organization to impact what's happening there. That's great.
I would say, interestingly enough, even in a large company, you might have a little bit of a valley of death, but maybe not a huge valley of death.
It's a valley, though.
It's a small valley. But no, it's great because, if we're doing something new with an additive manufacturing technique, to be able to go to the actual location where that will be implemented is great.
And do you work with external partners like entrepreneurs outside of the company or inventors? And
we actually consider the research center as kind of a hub for our relationships with universities, our relationships with other companies, startups, and the government as well, right? So it's kind of like we use our entity as kind of the conduit to actually have those large relationships.
That's great. And so it's a way to sort of now leverage the innovations that happen even external to GE Vernova and possibly get it to the point where it can be impactful to a legacy manufacturing environment. And that's great. That's a great commercialization pathway from concept to actual work in practice. Thank you.
Yeah, well, we talk about legacy industry and also aging industry. In any industry we're in, regardless, right? If you look at aircraft engine, GE probably have 70,000 engine in the fleet. Worldwide wind turbine about 250,000. Smart grid, we probably not that smart. Honestly, smart city, our city probably not as smart either. So we have to be humble to treat those legacy systems. While we're pursuing performance, we also have to worry about the resilience, the risks, uncertainties. So normally when we design any kind of a smart system, we divide into 4 quadrant space: visible, invisible, solve, and avoid. 4 quadrants. For those visible system, legacy system, you address not just solving them, avoid them. But most systems, you still don't know why they degrade, why they fail. Those have a lot of unknowns. You have to use a new method, new techniques to find those. That's how research is about. To predict, prevent, to avoid. If we deal with our system regardless, smart grid, the wind turbine, improve efficiency and reduce uncertainties, downtime. I think that's both ends need to have a balance. Either way, I think we can make our industry better, resilient, and sustainable.
Thanks, Jay.
For you, Diana, sure. You can have two answers.
So first, the questions about infrastructure, I just want to emphasize that we can also address legacy issues in existing infrastructure beyond manufacturing. So for example, transmission lines, the grid. We and AMTO are supporting advanced conductors that have less resistance than conventional aluminum or conventional copper. And these new materials can really help with reconducting transmission lines. So you can carry more electricity in the transmission lines, and this is really important when it's hard to build new transmission lines. But then on the manufacturing infrastructure side, one of the things we're doing is trying to maybe revitalize casting and forging. There are a lot of big components that are needed for energy applications, whether it's nuclear, wind, water power, also fossil fuels. And our domestic casting and forging industry is not, it's very thin at that large scale. But one of the things we're doing is investing in sort of new technologies that can extend the capabilities of existing casting and forging, while also investing in sort of alternative approaches that maybe incorporate additive manufacturing from the start, so that we have multiple possible solutions, including those that sort of build the capabilities of existing industry that may be may need some assistance to help it address some of the challenges of today for the energy applications.
Amy, did you want to jump in there on the comments Diane made about just re-energizing this casting and forging kind of like
one of our recipients is actually GE Verona in this. So
Yeah, I was going to point out that, borrowing from other industries is always a great thing to do, right? So the whole automotive industry and the giga casting capabilities that are there is something that I think we need to do better at in leveraging advancements in other industries. And I love the comment about, integrating additive manufacturing with casting, actually using additive manufacturing to print the mold and then use traditional casting capabilities. Right?
like a hybrid, kind of like a hybrid approach.
Yeah.
And John, Jay mentioned here in his, his 6 M's, but he mentioned this whole issue of like the importance of digital engineering. Essentially, have you found that you've been able to kind of leverage that? I mean, you were Honeywell. I would expect the answer is yes, but.
Digital engineering, absolutely. I mean, at Honeywell, we manufacture a lot of different devices, different equipment. Absolutely, it's important. I mean, we're leveraging now, like obviously more advanced robotics than ever before, things like that. Even in our own factories, in terms of the LNG business. Just a lot of that going on right now.
And did you find Jay made another comment about the ability to do more preventative and fault detection and things that improve reliability overall. Do you find that you also have that kind of vision and you share that vision for what can happen?
Yeah, absolutely. So, I mean, LNG plants use massive amounts of energy to produce the LNG. So any little bit of efficiency or uptime that we can provide our customers is highly valuable. So we invest a lot in that area. We connect their plants to our engineers. We provide tools, and we're doing some really neat R&D in the area of AI to essentially be able to predict the next upset, the next inefficiency that they might hit, and even in spots where they don't even, where a normal operator wouldn't look. The other point to make, I think, is like these are very high skilled positions for our customers, and in a very rapidly growing industry, what you find is there's very limited experience and really a battle for talent. And so our customers, these large LNG projects, are really looking for how do you upskill, how do you assist?
Yes.
So we build operator training simulators. We build digital twins of our customers' plants, provide them so basically they can train on a simulation rather than kind of go to the real plant and make a mistake. They can do that on a digital platform. So those are some examples, Cory.
Yeah, thank you for bringing up the upskilling to it. So critical.
John,
Sorry.
Yeah, that was very insightful, and you really, I think, segued into our next area here, which is, what are the critical skills needed for the future of manufacturing, and how can we support the workforce transition? So,
Jim, we planned that segue. We planned that segue. John and I talked before we were going to do that segue.
Oh.
I think John created that.
oh, okay. Oh, yeah.
But we can answer the
Great
question.
minds think alike, Cory. Yeah. Go ahead, John. Yeah.
Let me just maybe one other area I'll touch on and then turn it over to my fellow panelists is that, we are in our manufacturing facility, we employ hundreds of welders. And so there is still, while we talk about additive manufacturing and we're investing heavily in that, we're investing heavily in robotics, it's still going to trade schools and partnering with trade schools and making sure the trade craft is respected and really you kind of raise the profile of that kind of work. It's also investing in the skills in our facility. We have full-time trainers that help upskill our people that are welding on our big pieces of equipment, because that is important. We need to show our folks a career path. And so I don't want that to get too lost in the mix here of how critical that is.
Yes, it is.
To this industry.
It's great. Thank you.
Yeah.
No, absolutely. I would second that, right? I think GE Vernova just announced a future of energy scholarship for vocational and trade education, so I think it's a huge piece of the puzzle. In addition to the digitization, the transformation, and robotics, and all the automation pieces, it's also just that traditional vocational kind of activities that we really need to build up in the U.S. Significantly. My story is that, when I was growing up, I grew up in a small town outside of Pittsburgh. My father was not a welder by trade, but he had two welders in the basement, and it just became like that. To me, was normal.
Yeah.
Right. And I don't think people would even know what welding is today if you actually asked a high school individual what it was. Right. So I think we really need to bring all those vocational capabilities back, and I'm really proud that GE Vernova is offering scholarships to do that. So.
That's great. And Jay, you're involved in education quite a bit. I think you probably have something to say on this.
Well, I think there are three fundamental things going to continue moving faster, right? One is automation. To do things people don't do well, they don't want to do. Dirty, boring, heavy, dangerous, blah, blah, blah. Second, intelligent system. To do things human cannot do. I will inspect 100 features in 1 second. You blink your eye, half second passed. All right? Semiconductor, 2 nanofarad. Third, digital system. How to use the data to make decisions. Today, we use a lot of experience to make decisions. Judgment, not good enough. So if you combine automation, intelligent system, and digital system, then we're going to change. Because our engineers are trend-based, domain-based. Experience takes time. But today, knowledge moves very fast. You do ChatGPT, bingo. Here, what can you do? You know everything, what can you do? Right, execution. So you need good tools. Like I said, technology, tools, and talents. You gotta have good technology and tools to make you move things faster, right?
Yes.
So engineer have to use all the tools. You cannot just try and error yourself. You make virtual mistakes first, rather than make physical mistakes. Right? That's what AI is supposed to do. But we're not doing that. Even CEOs make decisions. Try virtual mistakes. Don't make actual mistakes. So we don't have a lot of tools today, right? We have a lot of stuff going on. We need to give good tools. Engineer can use it. Not have a good domain knowledge, but also have a good data discipline. Then you have a good drive this execution.
Yeah, that's great. You really corroborating what John was saying, how, make those mistakes in the digital world, in the virtual world.
I like that, virtual mistakes.
The virtual mistakes, yes. they cost a little less, a little less impactful. Thanks, Jay.
Diana?
I think, AI, you can take AI as a substitute for people's thinking, or you can take it as an extension of people's thinking. And I think it's really important as we think about the workforce, to capture the imagination of people and empower them in their own career so that they're learning to use tools like AI, not in a just keep fiddling with it until you get an answer that you like, but using it to really help you understand the physical system. So I totally agree that understanding the physics, the trade side of manufacturing is really important. And when combined with these, AI and other tools, you can be very powerful in terms of what you can accomplish on the manufacturing floor. But if you're just, sort of essentially playing a video game with your manufacturing facility, that's probably not so good.
You're right. It almost can serve as an apprenticeship, where you have a coach or a teacher, and then you have, they call it co-pilots kind of thing, but really it's more than that. If the domain knowledge is proper, then it can serve as a way of training, enhanced training outside. So I think that's a sort of.
You want to help people develop an intuition or develop their judgment about the physical domain.
The critical thought, yeah.
So what are the skill sets that you're looking for, or skill sets that are changing then with respect to, this, manufacturing and increasing these requirements, like you said, with the computer robotics, smart systems, but we still need, really good people for the welding.
Yep.
And for example, I love people on my projects where they just have not even, they don't have a formal college education, but they're invaluable in the process of getting something from development into commercialization. So, if you can, go down to a lower level or get to a level more granular around what are the skill sets that you think we should train or maybe retrain. Maybe we've lost a lot in that space. So I'd like to hear your opinions on that.
Any comments on that?
Go ahead, Jay.
Well, this is our job. I think, honestly speaking, I think we have to be humbly reposition our education system, because if you look at how each country does their own education, right? And the traditionally manufacturing world, you have a Germany focused on machinist. Everything's a machine, right? Mm-hmm. You got a Japanese focus on their craftsmanship, training, right? We have in the US focus on technologies. We need balance.
Yeah.
We need balance, right? So simulation is great, but if you cannot make a machine, doesn't matter how many times simulation you do, you're going to depend on somebody else. So we need a foundational change in terms have a classroom setting and go to the factories. And the discipline, co-ops, internships, like it used to be German diploma program. Of course, they are facing that out themselves. So I think we need to get them back. U.S. has a lot of co-op programs, like many schools, Cincinnati and Northeastern, Drexel and Worcester Poly, many, but you need more. Manufacturing is a noble profession. Be a noble profession, you have to invest people who physically solve the difficult to solve problems.
Yeah.
Right? It's not just working for wage, no. Today, I can tell you there are companies offer my student $250,000 for PhD in manufacturing, right? I don't want to mention name, but they are manufacturing companies in some sort, right? Because they have a technology, they have a great innovation to drive those talents. But we need to really rethink how we improve our system better, yes. And because our students are great, but we need more hands-on, more hands-on. If you look at casting, you're talking about welding. How many universities have welding? Ohio State used to have a welding department. No longer.
Yeah.
How many people have casting?
Yeah.
Large structural casting, exhaust case, jet engine, right? How many we have? If you look at how the Tesla make cars, 6,000 tons, 10,000 tons press, die casting machine. We have to buy overseas.
Yep.
I mean, think of this, right? Like as man, you have materials, machines, fundamental, you have to make it, right? But we need a place to train those people. That's what we don't have today. We need more. We have some, but not good enough. We're good, but not good enough. Yeah, we need to really make a change. Yeah.
It's great points because, being able to capture knowledge that allows it to be foundational across generations, so intergenerational knowledge. So there's not a recreation of the wheel each time, someone has a great idea or they want to try to do something, well, they have to start from scratch again or, semi-scratch or something. Preventing that from happening where we actually have, this information in place in a way easy, accessible, and then the critical thought, I think you were talking about this too. So if you combine what you said, Diane, and what Jay's saying, and critical thought and the hands-on together with the foundational knowledge in place, I think that's a good place to move forward. What do you all think about that in terms of the trajectory of this, keeping that in place?
Yeah, I think the way we refer to it is, you not only have the expertise in machine learning and AI, but you have to have the domain knowledge of what you're going to be doing with that, right? So if it's in manufacturing, you have the domain knowledge of what it takes for a particular manufacturing step, married with machine learning, AI, data analytics, that digital transformation piece. And then I think for the physical side of it, the vocational trades, coupling that now with robotics and automation. So it's not only just teaching welding, but it's how do you actually do that and think about it to make everything more automated, make it safer, make it higher quality. All those type of aspects, I think is to me, the word that keeps coming to my mind is that integration of the education piece.
Yes, and I'm glad you brought up the vocational piece because there's a thread there where now with these tools that we are developing, right, these digital tools, now you can break down the silos between disciplines as well. So, an engineer, that's designing a novel manufacturing technique or process can think about what it's going to take for the welders to do this properly and really integrate all of those disciplines in the beginning process of the conception.
Can I add something? I think we also need to have a little humility about, why are people not going into manufacturing? Folks who are graduating, in high school, graduating from high school, in college, in graduate school, why are people not going into manufacturing, and what would make manufacturing more interesting to them? I think it's important for us to also think from that perspective as well.
Well, to add to that, Diane, Jay did say it was $250,000 a year for some starting PhDs in manufacturing for, anybody with, supporting children or their kids going to college. It's an area that they might want to reevaluate. So that's really important.
Well, I can just add what the question footnote earlier, because if you look at today's manufacturing, right, no longer just the one site, one person, one machine type, right? Mm-hmm. We have to manage thousands of machines. You have to manage thousands of flip engines, wind turbines worldwide, right? You have 1,000 people for 1,000 machines? No, one person, 1,000 machines. Tools, right? Digital tools, fleet by fleet, smart algorithms, right? Remote systems, right? Integrate domain, human-machine interface. Those things. If you look at semiconductor today, the advanced foundries, right? The people work in the data room. Only experienced people work in the fab. Why? Those machines, $20 billion factory, the EUV machine costs $100 million above. If you're not expert, don't even touch it. 24 hours. Mm-hmm. Right? So most engineers work in data room to managing those parameters. You have to use a tool to managing those. No longer like an old foundry, $2 billion, $4 billion foundry. You can play around things. No, everything Daifuku machine running continuously. You can schedule in the critical, the cycles. And again, we're talking about today is really managing complex system. That's how we're going to do, right? The young people say, hey, you have such a kind of demand for skill sets, not just based on what you know, but also something you don't even know, right? So you train those people, and then people do attract them, those companies, yeah.
John, did you want to add something?
Maybe just a little bit onto what Jay was saying. There's complexity inside your own factory, and then there's the complexity of the supply chain. So for one of our large heat exchangers, it takes 10,000 things to come together just at the right time for us to deliver that on time. And so, not only are you trying to manage what's happening inside your factory, you're trying to bring in data from your suppliers, understanding cost, schedule, design changes, and then obviously managing all the issues that come up. There's a tremendous opportunity for AI in that space, looking around corners for yourself, trying to alert early on potential supply chain issues. So I think it's like inside your factory, but it's also that entire supply chain that you have.
Okay.
So basically, anything that can impact you, if you can, have a way of sort of managing those potential negative impact parameters and using the tools to develop the tools to help prevent problems and maybe even solve them before they even arise.
Yeah, or it could be positive impact too. You could see a market in the, over the horizon or something.
So let's bring our audience into the discussion with us. And, I think the first question here is, let's say, looking forward, what areas need disruption, and what are some of the potential disruptive technologies and materials in space? So who wants to start? I'll have it. Amy? Did you want to start with that one, or John, or
Either one.
Go ahead, John.
So let me think about where does the energy go in many of our plants, and like when you think about the chemical and process industry, it's low level heat release. So how can we take low, and there's lots been done in materials and different approaches, organic Rankine cycle. So how do you capture what we're already wasting in that area? So there's a lot of potential there, I think.
That's a great point. I know we were talking earlier, and you mentioned that how the amount of energy it takes really to get LNG to where it's liquid and basically you can transport it. But it's a great opportunity for folks in the room, our audience, to look into the energy efficiency of just trying to transport liquid hydrocarbons and trying to create liquid hydrocarbons, being able to do that efficiently, even more efficiently than what we're doing. So there's a great opportunity. Thank you for bringing that up. There's a lot of energy there. Yeah. Amy?
So I think one of the areas in disruption is, how do we use AI to actually invent the next material? How do we use it to look for PFAS replacements? I think that's one big area where really taking advantage of that capability to help us narrow down the number that we're going to screen, right, for a particular application. To me, I feel like we need to get better and better at that, and I know that there's groups at the Research Center that are working on that as well. But really honing in on that ability to reduce our experimental space, I think, is a huge disruptor that will be very beneficial.
Yeah, I think I agree. I think the fundamentally the computational materials going to move very fast, because we have to move from discovery phase to deployment phase. Typically, you take 15 years. Depends on what materials, from discovery to deployment. Too long, right? You have to focus on purpose, not just problems. Then you develop a process to make that purpose happen. So you need a computation and discover those something don't work. Then focus on those something possible works, rather try and error every single one. After you run out periodic table, done.
There's a finite amount.
Yeah, but you got to run those periodic table, right, to find out what things don't work, right? Doesn't matter battery and or what the materials. We need to predict those things and also make it producible, physical facility to validate, right? And eventually, the speed is very important today, not just how good we are, how fast we can make that happen. I think that's a national initiative. I think DOE, ARPA-E need to have a great job to make this happen, yeah.
We're trying.
And that's a very good point. I think you'll find a lot of our performers, when you go to the tech showcase, it opens later this afternoon, you know, they're trying to make widgets, they're trying to make things. Just talk to them how challenging just some simple items you'd think are simple, and to get it done in a timely manner and cost effective. It's just not that simple, yeah.
Another disruption I think we need is extreme energy efficiency in compute. So we know we have AI, you know, kind of on the scene, dramatically ramping up our electricity demand. And this is really a time when we can innovate across scales, from material and devices through architecture systems, doing hardware, software co-design for AI, to really get to the next generation of chips. We have an initiative called the EES2, Energy Efficiency Scaling over 2 decades, that seeks to increase energy efficiency over a factor of 1,000 over 2 decades from these types of techniques. I think it's really needed for us to fully capitalize on the promise of AI.
It's great, the hardware software co-design that stood out there. That's so you have a problem, bespoke problem that can actually, you know, benefit if you do the co-design properly.
Yep.
Here's another really good question, I think, from the audience is, where do you see the U.S. leading in manufacturing in the future?
Oh, I like that one.
So, who do you want to start? I'll start with Jay here. He seemed ready to jump out of his seat.
Well, I think we have a challenge to both to innovate and to sustain, right? We have developed for many decades of a good infrastructure. We have to make the better, safer, and more reliable. So that's a big thing to do, right? Another thing, we have to innovate some new stuff that people have not done, but have to with speed. Even drug discovery, you have to make it faster, right? Take 18 years to certify new drugs. No, take 7 years clinical trial, and 11 years you can do something. Same thing for material. Wow. So I think the aerospace, certainly, deep space and lower space, I do believe this is important, right? And you're talking about semiconductor, of course. You have a certain thing you must do. And the energy industry, very broad range. You got a different type of a transportation and alternative energy vehicles, right? And not just EV only, right? But of course, we need to have a balanced landscape of our energy portfolio. Right now, 43% of natural gas, 16% coal, 19% nuclear, 10% wind, maybe 6%, and the 7% solar. We can improve more solar, right? So we change the landscape to have more growth in our local industry. What government had to do something. It's not what I say.
John, yeah, U.S. leadership.
I'll pick off something a little less ambitious than space, though. You know, I think there's opportunity when we construct our chemical process plants for modularization here in the U.S. So, you know, all the factors here are in play for that. What is modularization? It's just simply prefabricating your process plant offsite in a more controlled environment. And then when it gets to site, it requires less people with less skill to put together. What does that do? That reduces schedule risk, it reduces cost risk, it gives more certainty to these big, ambitious projects that are needed. I mean, it doesn't matter what the industry is. My experience is in LNG, but in data centers and other power plants, modularization is really important. And then the U.S. has the manufacturing, it has the module yards, and it has the demand for these projects. So, you know, that's one maybe a little closer in.
That's exciting, and being able to actually to build out projects in phases, so now there's a way to engage the investment community, there's a way to engage the insurance companies, there's a way to engage folks in the project space to where they feel comfortable building things out, even phases, and having modularity just allows even our early stage investors or innovators to sort of foresee what they could do and to participate. So modularity, it's a great comment. It really allows a lot of stakeholders to get involved early. Thanks, John. Amy, any comments on it?
I think a great suggestion so far. I don't know if I have anything to add.
Thank you.
Can I just add something that's maybe a little twist on the question? I think the U.S. feels very comfortable with innovation and in some cases innovation for manufacturing, for the cutting edge, next generation. And certainly that's the role of my office, to really think about that and pursue that. But I think part of where the U.S. struggles at times is to hold on to that manufacturing that was invented here. And I think for us as a nation, that's actually a challenge that each of us in this room can kind of think about and reflect on how to address it.
Diana, do you think it's just too expensive to maintain and hold on, or is the portfolio so large you can only choose the best out of the portfolio? Or
I don't think the issue is that it's too expensive to maintain. I think it's almost that it's boring to cut all the costs of each little bit, and it's maybe more like we kind of as a our personality is that we want to move on to the next big thing.
Yeah, gotcha.
And not necessarily do kind of the boring tuning of everything to help it scale. And I think also certainly the policy landscape here versus other countries also plays a role there. But I think I think it is tough to keep manufacturing when we find it boring.
Yeah, that's a good point. The detailed engineering, the incremental detail engineering development involved in moving things forward, and actually having the resources for that as well.
Yeah.
Yep.
But that also that brings jobs. That brings
It does.
exactly.
Yep.
Security, national security, et cetera. I think we need both. We also need the innovation.
Thank you. Jim, did we have any more, or that's it? Or?
Well, I think unfortunately we're out of time.
I felt like we were just getting warmed up.
I know, we're just getting started. So feel free to come and talk to any of the panelists later today and to us. And we really appreciate everybody's time here. And again, thank you very much, everybody joining
Thanks,
us.
everybody.
And
this is
giving your
great. Thank
insights
you.
in manufacturing.
Thank you to the audience. Thank you for joining us.